Okay, in this video, we're going to look at operations on functions. Up at the top here, you can see I've defined what f plus g of x is equal to. It is just f of x plus g of x. You can see a subtraction, or a difference, f minus g of x, f times g of x, f divided by g of x. So we're just going to practice with some different functions, finding some operations. We're also going to look at the domains of these. You can read up here, the domains of f plus g, f minus g, and f times g are the intersections of the domains of f and g. That is the numbers that are common to both. And then f divided by g, it's special. It's the intersections or the intersection of the domains of f and g, but it also excluding the values of x such that g of x equals 0. So we'll talk about what that means when we get to that here. Okay, so we're going to start with two polynomial functions. Our f of x is 6x minus 3, and our g of x is x squared plus 4x minus 5. So we're going to start up here. I'm going to find f plus g of x. So this is just when we add the two functions together. So it's just f of x plus g of x. To simplify, we just need to combine our like terms. So let's see, we've got, x squared doesn't have a like term, but this 6x and the 4x are like terms, as well as negative 3 and negative 5. So we're going to combine our like terms to get an answer here. And so f plus g of x would be x squared plus 10x minus 8. Now, polynomial functions, the domain of polynomial functions, it's all real numbers. There are no restrictions on what we can plug in for x into f of x and into g of x. So with the domain of f being all real numbers and the domain of g being all real numbers, the domain of f plus g is just going to be all real numbers. So all real numbers, we can write out all real numbers, or if you want to write interval notation, it would be negative infinity to infinity, or all real numbers. F minus g of x, this is when we take f of x and subtract g of x. We do need to remember that when we subtract g, we do subtract every term of g, which means that all signs are going to change. So I made it minus x squared minus 4x plus 5. Once again, I'm just going to combine like terms. So we'll have negative x squared. Let's see, 6x and negative 4x would give us 2x. And negative 3 and positive 5 would be positive 2. Domain, once again, all real numbers. The domain of polynomial functions, always all real numbers. So if we're looking at the intersection of the two domains, it's still going to be all real numbers. F times g of x, this is when we multiply f of x and g of x together. This one's going to be a little bit of work here because we're multiplying a binomial times a trinomial. So I'm going to use the distributive property here. So I'll distribute the 6x. And then I'll distribute the negative 3. All right, so let's see what we have here. So we have 6x to the third plus 24x squared minus 30x minus 3x squared minus 12x plus 15. Then we'll combine our like terms. So 6x to the third. Let's see, we have a 24x squared and a negative 3x squared. So that would be 21x squared. We have a negative 30x and a negative 12x, which would be negative 42x. And then it looks like just that 15, so plus 15. Sorry, I'm running out of room here, so I'll write it down here. Domain, all real numbers. We are going to see something special when we look at f divided by g, but for now, all real numbers again. All right, so f divided by g of x, this is when we divide the two functions. And so f over g. So I'm going to put the function f on top and the function g on bottom. And if we could simplify this, we'd want to. I can tell it's not going to simplify, but I'll show you. It does factor, both the numerator and denominator factor. So from the numerator, I can take out a 3, and I've got 2x minus 1. From the denominator, I've got a trinomial, and I can factor it by looking for two numbers that add to 4 and multiply to negative 5. So those two numbers would be a positive 5 and a negative 1. So like I said, you can factor, yes, we can factor, but it doesn't reduce because there's not a common factor in the numerator and denominator. So you could write either the non-factored version or the factored version as your answer. It doesn't matter. Now with division, it said that we needed to find the intersection of the domains of f and g, which would be all real numbers, but it said we need to exclude any values of x such that g of x equals 0. So we're used to this. We've done this quite a bit, but we don't want to divide by 0. So any value that would result in division by 0 must be excluded from the domain. So we already know that this factors as x plus 5 times the quantity x minus 1. So we do not want x to be negative 5 or 1. I'm getting those numbers by setting x plus 5 and x minus 1 to 0. So our domain would be all real numbers except negative 5 and 1. Now, for something like this, I don't require my students to write it in interval notation. I'm okay with this notation here. But you want to talk to your instructor because if they do require interval notation, the interval notation for the domain would be this. It would be negative infinity to negative 5, negative 5 to 1, and 1 to infinity. So basically that's a way that we can use interval notation to show that all real numbers can be plugged in except negative 5 and 1. All right, next example. Now we're going to look at two rational functions here. So we're going to start with f plus g of x, which we know is just f of x plus g of x. Now when we're adding two rational expressions, we need a common denominator. So I'll show with a different color here. I'm going to multiply the first rational expression by x minus 5, top and bottom. Second one by x plus 4, top and bottom. Now I have a common denominator. I'm going to choose to add numerators and then distribute in the next step. So I'm not going to distribute yet, but you can if you want, no big deal. But I'm going to add my numerators together and retain my common denominator. And then I'll distribute here. So we have x squared minus 5x plus 2x squared plus 8x all over my common denominator there. So if I combine like terms in the numerator, I have 3x squared plus 3x all over x plus 4, x minus 5. Now, once again, you could factor the numerator if you want. There's a GCF of 3x. But if you factor out a 3x, you'll be left with x plus 1, which will not reduce. There's no factor of x plus 1 in the denominator. So I'm going to leave it like that, but feel free to factor if you'd like. Now, the domain here, you could look at the final answer because that'll give you the domain. We don't want to divide by 0. So we don't want x to be negative 4. We don't want x to be 5. You could also use what I had typed up at the beginning, which says that we look at the domain of each of the functions separately and we find the intersection. So the domain of f is we don't want x to be negative 4. The domain of g, we don't want x to be 5. We put those together. So we do not want x to be negative 4 or 5. Again, talk with your instructor. If they want interval notation, just make sure that you abide by their wishes. So again, I'm just setting these factors to 0, and that's what I don't want x to be, so I don't divide by 0. The domain of f minus g and f times g is going to be the same. We saw that, same rules. But when we get to f divided by g, we are going to have a different domain. So let me go ahead and because the rules are the same for the first 3 domains. Okay, let's look at f minus g of x. This is where we subtract, so f of x minus g of x. We do once again need a common denominator. I'm going to go ahead, so right at this step here, I have a plus in between because I was adding. Instead of, getting my red marker out again or pen, I'm just going to take this here and just make this into subtraction. So it's going to be x times the quantity x minus 5 minus 2x times the quantity x plus 4. So since I had already found f plus g, figure might as well just use my work here. Oops, I made it, sorry, this should be a plus 4. I apologize, that should be a plus 4. So this should be a plus. Sorry about that. Okay, x minus 5. All right, so I'm going to distribute again. I'm going to get x squared minus 5x minus 2x squared minus 8x all over my common denominator. Combine my like terms. Sorry, I'm all the way up here. So it looks like this time I have negative x squared minus 13x over x plus 4, x minus 5. And we've already got the domain filled in. F times g, I'll show it over here. This is actually the easiest of all of them. So we're just going to multiply the 2 functions together. When we multiply 2 rational expressions, we do not need a common denominator. We just multiply straight across. So if you multiply the numerators, x times 2x, you're going to get 2x squared. And then if you multiply the denominators, well, it's just going to be x plus 4 times the quantity x minus 5. So multiplication is pretty quick. Okay, division. Okay, so f divided by g. So this is when we put f on top and g on bottom. And of course, we're going to want to simplify that. We don't want to leave our answer like this. So I'm going to write this horizontally. This is the same thing as x over x plus 4 divided by 2x over x minus 5. Now we know when we're dividing two rational expressions, we can multiply by the reciprocal of the second. So I'm going to flip the second one and change it into a multiplication. Now there's not too much that we can do to simplify, but there is one thing we can do, and that is we can cross cancel an x. I'm going to get rid of those x's there. All right, so our simplified answer is x minus 5 all over 2 times the quantity x plus 4. Feel free to distribute the 2 if you would like, but it is not necessary. You could also leave it in factored form. So this is our answer for f divided by g of x. You know, I had room up here, I guess, for it, but I'll just leave it down here. So now for the domain, so we're supposed to look at the domain of f, which we know is x cannot be negative 4. Then we're supposed to look at the domain of g. So we did this already for the first 3. For g, x cannot be 5. But there is an additional number that we want to exclude from the domain of f divided by g. And don't just look at if you look at your final simplified answer, you're not going to get the correct domain. You're going to miss out. So if you look just at the final answer, it kind of looks like x just cannot be negative 4. But there's more to it than that. So we do the intersection of the domains of f and g, as well as we also do not want g of x to be 0, because this entire function g is in the denominator. You're taking f divided by g. So you also do not want g of x to be 0. So there's one more number that we're going to remove from the set of all real numbers to get the domain. So I'm going to set g not equal to 0. And I could multiply both sides of this by x minus 5 to clear my fraction. So that'll get rid of that there. 0 times anything is still 0. So really we just have that 2x cannot be 0 and x cannot be 0. So our domain for f divided by g, let me go ahead, I'll write it up here where I have a spot for it. So domain is x cannot be negative 4, 5, or 0. So we have an extra number that we have to remove from the set of all real numbers, and that is the number 0. 0 is what makes g of x equal to 0. You may be wondering why, because if you look at the simplified answer, it looks like, oh, I could plug in 0. That's not an issue. Oh, I could plug in 5. That's not an issue. But if you look back to the unsimplified answer, oops, I don't know what I just did there. Oh, there we go. You could see why you don't want any denominator to be 0. So you have a denominator here, you have a denominator here, and you have a denominator here. So you don't want any of those 3 denominators to be 0. So that's why we have 3 numbers that we do not want x to be. Okay, last thing here is, what if instead of having an x, we have a number inside parentheses? So suppose we want to find f minus g of 3. So there's 2 ways to do this. One is you could find f minus g of x first, and then plug the number 3 into what you get. So let's do that. It's a kind of a longer way to do it. So I could take f and subtract g. Now remember, when I subtract g, I do want to subtract all terms of g. So all terms are going to change sign. So I get negative x squared minus 4x. That's it, because the negative 2 and the positive 2 cancel. So I've got f minus g of x. So if I want to find f minus g of 3, then I would just plug 3 into the function here. So I would have negative 9 minus 12, which would be negative 21. Okay, so that's one way to do it, is to actually find f minus g of x and then plug 3 into that. Another way, though, is by definition, we have that f minus g of x is, of course, we have this on the previous page. This is just f of x minus g of x. So it would follow then that f minus g of 3 would just be f of 3 minus g of 3. So I should put kind of like an or. We're not, you could do it this way, or you could do it this way. So, and I feel like the second way is going to be faster. So to do f of 3 minus g of 3, well, we just find f of 3, which just is substituting 3 into the function for x. So if I take 3 and I plug it in, I would have 9 minus 2, which is 7, minus, and then I find g of 3. So I'm going to plug 3 into that. 9 plus 21 minus 2, which would be 28. And then you just subtract and you get negative 21. So same thing, I'll just put a little check mark, exact same answer. I did not have to find f minus g of x. I just had to find f of 3, g of 3, and subtract the two numbers. I'm going to use that second method for f times g of 4, especially because I don't want to multiply a binomial and a trinomial again. So f times g of 4 is just f of 4 times g of 4. So let me show more work this time because I kind of did it fast above. So f of 4 would just be plugging 4 into the function f for x, and I get 10. G of 4 will be plugging 4 into the function g for x. Oops, sorry. Apparently my computer wants me to restart Windows 10. So plus 7 times 4 minus 2. So let's see, 16 plus 28 would be 44, minus 2 would be 42. All right, so to finish, all I have to do now is take those two numbers and multiply them together because the operation is multiplication. So answer is 420. And I never had to find f times g of x. Okay, guys, well, thank you for watching, and I hope you have a good understanding of operations on functions.